Hello, everybody. My name is Natalia. I'm a PhD student and founder. And I would like to tell you more about the topic, which is deriving insights from low-cost sensor networks and how to actually make them useful to people. So basically, I'm going to switch to the presentation slides, and you're welcome to suggest any questions in the comment section, and then I'll come back to questions afterwards. So I'm going to share my screen. So basically, a little bit about me. I have background in art and design, as well as chemistry and engineering. So I have been working on building sensor networks and data pipelines for the last about 9 years. I have also founded 2 companies and work in advanced computing as well as part of this job. So when you think about this, cities, we hear all about this new projects, building sensors into buildings, building them into our roads, into our infrastructure. And there's a couple of very interesting projects, smart city projects going on everywhere in Asia, in Europe, in North America, in Australia. But to actually build cities smarter, we need to think about 3 major kind of categories of things and questions. First, we have to think about the sensors that go into those cities. So how do we design the best sensors for the application? Second of all, we need to think about the data quality and, how do we actually make those sensors work accurately and reliably? And then finally, we have to think about how can we actually use those devices to make our cities smarter, to make them adaptable, to make them basically help us design better interventions, such as laws policymakers make, or urban planning decisions, or maybe even real-time operation of things like streetlights to reduce traffic, to reduce air pollution. As well as making maybe smarter decision about infrastructure and how we transition into hybrid or electric vehicles. So I'll start with the measuring aspect and then move through the others. So when you think about the measurements that we make and the sensors and the sensor networks, there's a couple of trends going on. So first of all, we are in the field of many sensors coming to market. So from companies throughout the world, we have sensors that tracks all kinds of things, and this market is growing exponentially. As well as we have a lot of data that we're generating using the sensors, and we need to figure out, best ways to make use of this data and how to also make this data reliable. So I have been designing and building these types of devices, specifically in the field of air quality monitoring, and setting up networks of these devices in the city of Toronto, calibrating them and putting them out there in the street poles. And what I have been doing is kind of mapping those measurements and, figuring out, first of all, how do we make the sensors work well and work accurately? And second of all, how do we derive insights from those sensors? How do we actually, help use them to help us make the best decisions? And this is not just my lab. All over the world, we have companies, we have government and other projects setting up either networks of devices or basically using the data from a bunch of different places, compiling into one platform and actually using it to make better decisions. But can we actually trust this data? And what is the kind of way we can make it useful? So first of all, I want to start looking at the data sheets and how, starting when you first start a project and you decide which sensors to use, what are the things you should be thinking about? So this is a standard data sheet for one of the air quality sensors commonly used in the field. And you might notice a couple of things. So it gives you sensitivity characteristics. It gives you some performance specs on temperature and humidity dependence. And these are all good things to know. But what's important is that a lot of these low-cost sensors that are so seemingly easy to access and could potentially make a very interesting devices and networks, one thing it's important to consider is how accurate they actually are. And more often than not, low cost actually means there is some cut corners around the quality of the sensors. So this is something to think about, and this means that we have to test them accurately, as we have learned from my work. So what are the kind of things that we come up when testing the sensors? And I should mention that some of them are better than others. Like, it depends what parameter you're measuring. Usually, it's much easier to get accurate measurement of temperature and humidity than, let's say, some pollutants, like some gases. But often you'll come up through several issues. So first of all, you'll have sensors kind of bias. So you'd have overestimating of the measurement signal. So you have to calibrate it. So even though the datasheet would tell you some measurements or some coefficients, it's not always the case that it works in your environment exactly the same way. Second one is underestimating, again, something that calibration can solve. And then third of all, false results. So sometimes you'll see this outliers or these measurements that don't really make sense. So this is things that are really important to consider before those devices are out there, as well as over time, because there is things like decay and drift. And we have seen lots of this happening in field. So this is some of the devices that we have put out, and things like corrosion, things like dust blocking the inlets and snow impacting the measurements. Those are all the things that we need to think about when designing those networks. Another big aspect, and I think this is something that a lot of groups don't really think about too much when putting these devices, is how actually representative they are. So you might go ahead and calibrate the devices at one location. In this case, we calibrated this device at a low traffic site for a specific pollutant, in this case, nitric oxides. It's a pollutant in the air, which you can see in the top graph. And then in the bottom graph is we actually wanted to test how well it performs in the different site. So at the calibration site, it was working very well. Even beyond the calibration period, it was giving good estimates. But as soon as you place the device at a different location, the performance characteristics might change a lot, just because of things like interferences, because of things like different mixtures could be impacting the sensor response. And if you don't have a way to calibrate it or to validate the devices at another location, you might never know that this is the case. So it's very important not just to calibrate them well, but actually test it in a number of different locations. Another case, and this is also shown by a number of different groups, research groups, and also from company work, is that the response of sensors can vary depending on the types of things you measure. So this is a very common sensor that's used in a lot of research studies for air quality. It measures particles, and it measures them by scattering light. And what a lot of people didn't realize is that, there is different types of particles out there. So even if you focus in on specific kind of source, like burning something, so burning wood, burning paper, or burning kerosene, it can result in a very different types of measurements in this sensor, just because of the different ways in which this particles scatter light. So, and this could basically overestimate or underestimate your concentration depending on what you actually want to measure. So this is something that's really important to kind of realize and think about. So we see all of those new devices being introduced. You might have seen in the news different types of devices being available for monitoring things in your home, in your city. So those are specifically air quality devices, but there are many others with other types of sensors. But a lot of those sensors face the same kind of problems that I just mentioned. So it's really key to really understand them. And, in some cases, those problems might not be relevant to the application, but it's important to think about them and kind of take that data with a grain of salt. And again, there is recent papers published in Nature talking about this and how much can we actually believe the data we generate. So what I want to highlight is basically that, IoT requirements are not made equal. So while data quality is extremely important, like very high accuracy is important for regulatory and compliance type of studies, and it usually comes at a cost. So those calibration studies are very expensive and resulting in high cost of those devices, and as well as time for quality control. There is some application which they're still useful. So for example, if you're doing studies to supplement existing network, if you're designing IoT sensor networks that's just for community monitoring or your own home monitoring or educational projects, there is things that you can do still without having to have the most accurate sensors and the most accurate calibration. So there is stuff that you can do, for example, comparing different sites with respect to relative measurements. But it's important to realize that the data that you generate is not going to be on the same level as the regulatory data. So one other thing I wanted to mention is that the sensors that you pick for the studies can really make a huge difference in your performance of your devices. So there's, as I mentioned, millions of different types of sensors available. Even just for air quality, this table is not comprehensive, so it lists some of the common sensors, but not all of them. And some of them have certain advantages and disadvantages. So for example, depending on the length of your study, depending on how quickly you want to measure, depending on what kinds of temperature and humidity you expect at the site, it's really important to decide which sensors to pick. But what I want to say also is that data sheets doesn't really tell you much. So we need a better way to actually, because as I mentioned earlier, most of the sensors that are low cost don't go through a whole lot of quality control. There is certain things that we need to think about, how to make those devices more reliable, how to actually know what is the real performance spec of those sensors when they're tested in field, and maybe use beyond their spec in the datasheet. So this takes me to another aspect I want to talk about, which is analyzing the data and how do we ensure high data quality. So this is this shows an average type of data pipeline that we use for analyzing the data coming from the sensors. So first you have your device, you get the data out of it. Maybe you'll actually combine it with some open data sources such as traffic data or weather data or other types of data that's commonly available now. You'll usually have to do some reformatting and cleaning, removing things like outliers and different measurements that are not real. So this is another aspect that's important. You'll then go through the transformation, so maybe extracting, log transforming the signal or extracting certain features that you care about. You'll explore the data, so maybe use clustering and really analyze how the distribution looks like. And finally, usually you'll build a model. So the data coming from sensors obviously is usually not direct measurements. So most of the time it would be some sort of voltage or current or resistance measurements. You'll need to convert that to the actual measurements, either using the data sheet, which is not perfect method, but ideally you would calibrate the sensors against some known standard. But one thing that I came through a lot of the times is this data is usually, especially the data that might be collected by some sensors and found online. One of the challenges of using this data is that it's usually not very properly annotated. So you would see either voltage measurements or concentrations, but you wouldn't actually know through which parts of this process those measurements went through. So it's really hard to use some of the existing open data because of this. And so, which makes me think, we need better ways to track which steps data went through and how can we actually improve that tracking and make the resulting measurements more accurate and more useful. So there is many interesting approaches that have been proposed by a number of different researchers and company leads on analyzing the data, so and improving its accuracy. So there is things like signal processing, using unsupervised models to build better results using data that might be nonlinear and not perfectly easy to model. There is new calibration methods where you would have, for example, if you have a sensor networks, you would have different like traffic, like a public transit calibration system. So you would have like a node, a sensor node, and it would be recalibrated at a regular period using a device that's kind of moving in between the network and adjusting the measurements continuously throughout the day. So this is like one of the really interesting methods proposed. There is sensor array approaches where you basically combine sensor signals. So while sensors might not be very accurate or precise themselves, by combining the signal, you can improve the accuracy through differential signal analysis. And then there is also fusion of the data sets where you would take your data set, for example, whether it's like a traffic or air quality data or some other data, and you would compare it to another source. So for example, satellite data sets that have recently become available from NASA openly, so that you can adjust your measurements based on that. So those are just some of the methods that are available for improving the quality. But what I want to also mention is that we need better ways to compare and annotate methods. So just as I mentioned for the data pipelines, we really need to understand, what kinds of techniques people use in analyzing the data and properly annotate the data that we make available online. Basically, this is a collaborative effort. So, scientists or domain experts in certain fields need to be collaborating with citizens and data scientists and developers to improve the data quality. So each field can actually contribute in many ways to our understanding. So for example, domain expertise can help inform citizen science, optimize algorithms, while those IoT networks that get established by citizens, for example, can have annotate data and provide really high spatial resolution of measurements and prioritize algorithm development, while developers can, help train better models. So it's a collaborative effort, and we need better ways to collaborate. So finally, I want to go to the third aspect of this talk, which is adapting this measurements and analysis to actually real decisions that we make. So IoT is, becoming very widely available through all those sensors and all those data sets that are available online. But how can we actually use them to drive decisions? So, for example, we see this all the time in the news, like new taxes that are introduced on different types of cities, like to prevent traffic jams or to ban certain types of vehicles or change urban planning in certain ways, introduce new parks. But how can we actually, implement those strategies such that they drive the most return on investment? So this is something I think, sensor networks can really help with. And maybe, the decisions that we make in the future will be based on actual real case studies or data sets that we have collected in the past through those sensor networks. So I want to talk a little bit about the projects that I have been running and use it as a case study. So basically, OpenMetaData Project is a project of Weaver, and what we have been doing is using the data sets available online to develop basically a distributed open database for different types of things. So first thing that we are interested in is sensors. So specifically, we are looking at different sensor data sets and trying to develop ways that we can better suggest to people, what is the best sensor in case they want to build their own sensor network or their IoT setup. What is the best sensors for their context, their needs, their budget, their environment, so that, they actually get the most out of it. Second of all is building better sensor models, which models work better for certain types of sensors. So let's say you bought the sensor out of the shelf from the manufacturer, and through this database, you would actually know which models perform well under which parameters or which conditions. And finally, interventions. So as I mentioned just now, is what we are trying to do is, figure out how can we use this sensor data to make better decisions in the city, like whether, for example, if you see increase in certain types of pollutant indoors, what is the best option for you given your circumstances, given the kind of profiles that you see in the sensor measurements? Is it to, maybe just open the window at certain types of day? Is it to buy an air purifier of certain kind? And how well has it actually worked for other people? And on a larger scale is maybe helping governments, use this sensor data of these networks deployed outside to make better decisions about urban planning, about policies they implement. Basically, as part of the system, we are building a distributed sensor state machine, I call it. It's basically a way for us to use the different events that happened in the sensor lifetime to really have a unperturbed, continuous record of the measurements. So if you will, it's a database, but it's a database that's basically accessible to anybody, and it cannot be rewritten. So similar to the way blockchain works, we are building this kind of open source method for people to annotate and store their data. And not just data, but metadata, such as when the sensor has been calibrated or recalibrated, what are the different interventions it was used in, and when the device is updated, so that it cannot be lost. This information cannot be lost, and it can be used to make better decisions about how we use the data. This OpenMetaData project, we are currently working on bringing new collaborators. So if you're interested in making sensor data accessible or in either of those areas of data aggregation, algorithm development, or mapping, please contact me at info@weaver.com, and I would be happy to collaborate on this project. So I would like to summarize that, thank you very much for coming and joining this talk. And basically, feel free to contact me or message me or connect with me on social media, and let's keep in touch. Let's make our data more accessible. Thank you. Okay, so just going through the questions. So I have a question from Dr. Harsh Verma about what is the aggregation platform used by me at this time. Basically, we went through a number of different data aggregation platforms over the course of my projects. So for my research, we have been using AWS a lot and other online databases. However, one of the challenges that we encountered is it was very difficult to track all this metadata and track it reliably, especially if you're collaborating with a lot of people. So this is why we started this project focused on actually collecting the metadata and creating this open distributed database. So this is how I hope the data will be tracked in the future, so that it will make all of our efforts a bit easier. So I have another question from Dr. Verma, and he mentions, is this a university project or an industry project? This is actually a project that was offshoot of a university project. So the idea from it started from university, from when I was doing my engineering degree, PhD, but it has moved into kind of open source offshoot of company work that I have been doing. So At Weaver, we have been developing this new sensors that help improve our indoor air quality and help our, improve the performance of our indoor purification systems, such as HVAC filters or other types of purifiers. But then what we realized is there is really, this data can only go so far. So we need to combine different data sources together. But there is a huge limitation right now with, analyzing and knowing the data quality of the devices available. So we have started this open source project funded by AI grant from Xamarin Founder. So this has been very helpful to get it started, and we are looking forward to collaborating to make this, project not just focused. Right now, it's mostly kind of the most data sets that we have are focused on air quality, but we want to expand it bigger beyond that. So we started putting together other types of data sources from like traffic, weather, and so on. But if you have interest in this area, or if you have data sources that could be combined, or maybe use as a case studies to test this system and to develop it further, let me know. And so I actually have a link to the slides that I can share. So that's the link. You feel free to download them, and I'm sure they will also be made available through the Intel platform. Yeah, and I'd like to be connected going forward, so let's keep in touch. Thank you very much, and look forward to staying in touch. Thank you for coming. Have a good one.